Now, let me introduce our next speakers, two of them. Efficient deep active learning for text processing, the new old way to deal with the annotated data scarcity. A very, very relevant topic. Is going to be highlight of the topic, which is going to elaborate on how the active learning can tackle the deficit of annotated data, which is one of multiple relevant problems where machine learning is used in different industries. Speakers are going to provide an idea of possible areas where the active learning can be used and new ways which have been developed to resolve these problems. Our distinguished speakers, the AIRI A.Szelmanov specialist and the leading specialist in data, Sber A.Цвигун. Good day, dear colleagues. My name is A.Цвигун. I'm the leading expert in Sber, and together with the A.Szelmanov, who is a head of mine, who is the CEO of Artificial Intelligence Research Institute, we're going to talk about the effective deep learning for processing text data, which will allow us to accelerate active learning. I'd like to give the floor to Artem. Artem, hello. Over to you. Good day. Unfortunately, cannot be today with you at AIJ. Now I'm at the conference of NLP, where we can present one of our papers. But we're going to talk about the ways published in different conference ACL this year. We're going to talk about the active learning particularly. Very often, we want to introduce machine learning and AI in production, so on and so forth. But to do that, we need to have some examples where people are going to annotate, to have text. So we need to have annotation. Annotation is a long and time-consuming process. I'm responsible for the team, the objective for which is to create the methods which can provide machine learning model with a minimum supervision for labeling and annotation. And active learning is one of the approaches which can reduce the cost of labeling and workload 2 to 7 times. We have a big data set which we like to label, and we have a data set consisting of 10 or 100 examples and human annotated. Major idea of an active learning that not all the examples have the same value to train our model, and we will be choosing only those examples which are most informative ones. Since at different examples we train machine learning model and apply it to non-labeled data, and if the model is not very certain, it is informative. So the data is annotated in this way, and we can reduce the workload. And the active learning is very useful when labeling is very sophisticated and crowdsourcing is not applicable. So when we use medical data labeling, legal documents labeling, and so on and so forth. Active learning is not a new one. It was connected with many problems, actually. First, we need to create a model of machine learning without understanding the field of expertise, without understanding informative things. Secondly, we need to train the model using low data set first iterations, and we need to do it fast. Active learning is a process of interactive nature. Any delays might not be appropriate. That will increase the labeling cost. So far, we have received a very important tool, which is PERT, Electra, Roberta, and so on and so forth models. They give the vector representation over word, which is a universal representation, which gives a state-of-the-art for many tasks in this particular field. Pre-training gives opportunity to fine-tune these models using small data sets. Moreover, transformers, compared with other models, are better trained, faster trained. So, pre-trained deep models gave new impetus to this active learning. So we looked into this pre-trained learning with the help of the transfer learning. We have a lot of results, but I'm going to talk about two of them. First of all, we've demonstrated that pre-training increases the effect of active learning. In this graph, you can see that we can get 99% of the score of the entire data set of the model we would have got without this approach, using all the data, which is much better compared with the conventional models like B-term or CRM. Out of this table, next slide, please. Okay. Secondly, out of this table, you can see transformer utilization, pre-trained transformers. We spent less time on one iteration of active learning compared with the conventional models of us tend to build CRF, which can help us a lot. All three problems which we have looked into somehow have been solved. But that's not everything. And very important problem connected with active learning, that we cannot use different models to choose instances for annotation trained other one on the labeled data, which can be seen from the Lowell paper 2019. So if you use one model acquisition to create a dataset with AL and train another model successor on the result dataset, you can get a performance drop, actually. Same result can be seen from our paper from transformers on blue line. You can see that using distilled and trained Electra succeed, the quality of the model, the performance of the model is dropping. We cannot use it for choosing the data set and train very heavy models like Electra and put it in production pipeline, which limits the opportunities for active learning. And A.Цвигун is going to elaborate on other problems we face. So we saw that acquisition succession mismatch leads to lower performance rate, not only in case when these acquisition successor relate to different types of models, and even in case when they are of the same models, which are transformer-based models. For we decided to check the following hypothesis: what if acquisition is distilled from the successor models? Logic says that they need to have different probability rates, so there is not going to be performance drop. In our paper, we did this experiment and we found out if we use distilled acquisition models, there's not going to be performance drop. On the slide, you can see the graph where the blue line corresponds to the experimented distilled acquisition model, and BERT is a successor model. It's practically in line with usual bad setting. But there is another problem. Not for all current models there are distilled and filtered variant, and these options are not distilled in high-quality approach. In this respect, there is a question whether it is possible to use powerful explicit models like Electra, because distilled model allows you to avoid performance drop. So we have offered our pseudo-labeling for acquisition successor mismatch solution, which works in the following way. On the slide, on the left-hand side, in the bottom, you can see the starting point. We have some kind of pool of labeled data where we're going to start our active learning cycle. As acquisition model, we're going to have a lightweight model like distilled, and we're going to have iterations of active learning applying annotator for labeling of data. Unlike the regular active learning, at the end of the cycle, we're not going to train the final model and to have forecast on unlabeled data on a test data set, but we're going to add intermediate labeling step. At this stage, the model distilled from the acquisition model will be trained on the current labeled data set, and with the help of which we are going to label the rest of the data set. So we have the outcome data set where big part is labeled by labeling model with a human annotated part, which is not that big. Then we have a powerful model Electra. We forecast on the tested data and we get the results. On the slide, you can see the curve where the red line correlates to our algorithm plasm. The green line corresponds to the conventional setting of active learning, where the acquisition and successful models are the same, and we see that the plasm allows us to reach at least the same results, but it accelerates the process of active learning at the stage of model training and forecast for unlabeled data by 40%. Therefore, plasm allows us to use different models for acquisitions and for successor as acquisition succession models, but in fact, these are not the all problems we face. There is another problem impeding. Very often, unlabeled dataset has 100,000 and millions of examples. So when we forecast for non-labeled pool of data, even though we use the log regression, it's going to take a lot. And if we bear in mind that the iteration of active numbers is 15, 10, 20 to 25, is going to take a long time for processing. To solve this problem, we decided to look at how improbability assessments are connected among the models trained using different iterations. You can see different columns, the number of the current iteration 1 to 6, and in lines we see the share of examples where the model is trained on the current iteration is less certain. So, and then we see that the fraction of this that would be standardly selected on the current AL iterations contained in top K% on certain instances according to the acquisition model on the previous iteration. So we see the share which I've set already, and it's going to be contained in this environment of those examples chosen by next models. So we can interpret in the following way. What if next model makes prediction not on the whole pool of unlabeled data, but on top K% where the previous model was less certain? So which number of examples, important examples, we're going to retain? If we take top 50%, we will not lose any important examples. Only 2% on the first iteration and 0% on the sixth iteration. So based on that, we offered unlabeled pool sampling, which is UPS model, which is uncertainty estimates updated only for a fraction of instances, and sampling of an instance of the current iteration is performed according to the Bernoulli distribution with parameter dependent on the model uncertainty in previous iterations. We sample examples not among this top K% in case when there is an important example is not among this top K%, not to have the zero probability of taking this example. On the slide you can see the curve where the black line is using UPS and plasma algorithms together. It's not losing to active, conventional active learning in green line and the plasma in red line. We believe that, and we can see that UPS allows us to speed up the process by 50%, twofold increase. And combining UPS and plasma algorithm allow us to decrease the time by 60%. Using these two algorithms makes the process of active learning is threefold faster, 3 times more interactive. Therefore, our examples considered, the problems considered, connected with active learning, we have managed to solve all the problems, but the problem of deep active learnings are in huge abundance. So whether we can create the improbability assessment, or can take a batch of problems in more informative way, can we maximize not only informality of each batch of the example in separate, but maximize information essence of each batch separately, so not to have overlaps in describing scenarios. And the major problems, not only deep learning, active learning, but machine learning, which hyperparameters we need to use. We have standard hyperparameters for deep learning as the size of the batch, in training the number of AIRI, the step of learning, and the major hyperparameter for active learning, which models are to be used for acquisition and for successor as an acquisition successor model. As a different data sets, we see that state-of-the-art quality can be demonstrated by different models. So for the task of recognizing essences, named essences, Electra demonstrates state-of-the-art results. But for the classification, Roberta and ExcelNet are much better. I give the floor back to Artem. Thank you very much, Akim. So let's wrap it up. What are the takeaways? So there is always an aspiration to create rules, but do not write handcrafted rules instead. Innovate quickly and do not create these limitless rules. Active learning is a good technology which is very useful when the task is very complicated. When you have a very complicated area, biomedicine, legal documents, so on and so forth. The task connected with business logic and annotators from crowdsourcing cannot label these data. The third, our algorithm allows us to accelerate iteration of active learning, which makes the technology more interactive and applicable in real life. And finally, our methods allow us to create active learning as a more universal technology. That's it. Thank you very much. These are all takeaways, and we are ready to take any questions you might have. Artem, Akim, thank you very much for an interesting presentation. It seems to me that the task you're dealing with is very, very significant for all those data scientists we have. We have several minutes for Q&A session. Let's take some of the questions. Let's start with the following thing. What are you talking about? The batch-bound approach, which would allow to assess the information essence of the batch in general. Artem, can you take this question, please? We do know about the batch-bound method. This is one of these approaches to choose the example out of the group of examples. It's not the single one. There are many other approaches. Batch-bind problem is that there is no efficient implementation of batch-bind for real practical implementation. This is one of the approaches which allow us to solve the problem with choosing a group of informative objects, but from practical point of view, it is not that easy implementable. So our task is to find the algorithm to be of high quality, on the other hand, to be very fast. So these technologies are being developed by the companies, IBM, Google companies, but we have our own ideas. Artem, thank you very much. And another question. I'd like to ask Akim to answer this question. APS resembles game search. Do you do backtracking? Do you need to adjust the evaluation steps depending on the step? Of course, these should be adjusted, but in our case, only for a particular share of examples where during the previous iteration this model was not that certain. For top 10 to 20, the uncertainty level might change, but as a result we get the example close to 20% of the most uncertain level. But we do believe that out of the examples left where the model was most certain, we won't have those examples. That's why we don't need to adjust this approach. But for UPS, during the first two iterations, we readjust models for the whole pool of labeled data. On the first iterations, these evaluations of uncertainty will be changing. Akim, thank you very much for your answer. I'd like to thank Artem and Akim for a very interesting presentation. So this is active learning. We are following your results. We do wish success in your research, and I am very happy that I am part of your team of AIRI team. Thank you very much, Semen. Dear colleagues, unfortunately that was our last presentation. We were very happy to share our results with you concerning a new AI research institute. Unfortunately, we were not able to cover all the topics. We have a lot of interesting presentations. We are going to keep you posted with our news from different departments and different groups. It was a great privilege for me to be moderating today's session, and we will be actively participating in the AIJ 2022-2023. We are very open to collaboration, and the main conclusion which we'd like to convey to you, the first one actually, is that we're trying to create the technologies of AI applying in different industries, in different scientific fields, and we've demonstrated in genomics and genetics in search for new technologies against current pathologies. We demonstrated how new materials can be synthesized, and this is just a tiny part of what we are doing in our institute, involving more than 100 scientists. We demonstrate that at the edge of two big worlds in research and we can create interesting, which are very relevant for ESG, which is a key topic of AIJ 2021 in social boost, and we intend to create very useful technologies. We're open to our scientific community, we're open to the world, we're open to any type of collaboration. Dear colleagues, thank you very much for all the listeners and our audience being today with you. You can find our contact details on the website. Those who wanted to ask questions didn't have this opportunity, go to our link. All the speakers can be found in social media. Contact us, we'll be happy to take all your questions. Thank you very much for your attention once again. All the best. And tomorrow we are going to have an interesting part of our conference as well. Thank you very much. Good day.